the DBCC page with the 211 argument, which is the data page that was modified, we can actually figure out slot 20, row offset 80, exactly what was done to that data row. So if we look at the starter transaction, that's circled in red here, that's the actual data that was added to that data page. But as well, if we look at the DBCC page output, it's not captured here on this slide, but it also tells us what the start of the actual column was. So the start of the column was actually prior to the data modification. The reason this was done is SQL Server is intelligent. Depending how you look at it, it's either intelligent or lazy. If it sees a value on the data page and it's the same value that it has to write in the same position, as opposed to writing the same value over top of the existing value, it will skip writing that value and just increase the offset by 1 and start writing any changes to the actual data files. So jumping to the next slide here, looking at row log content 0, which is what the data was before the modification, and row log context 1, which is what the data was after the modification, what the actual modification did. So based on the previous slide, the price column is what was updated. Row log context 0 was 500.00. Row log contents 1 was written decimal 50, and the 20s in hex translate to spaces. And SQL Server put those spaces in just to overwrite the other information that was there so it didn't skew the results. So by adding the last 3 slides together, the first record that was affected by transaction 814 had the price column updated from $3,500 to $3.50. And the reason why that 3 comes into play is, again, the offset on the previous slide had a leading byte of 33. That 33 is the hexadecimal representation of a 3 in ASCII. So when doing log review or log analysis with SQL Server Database Forensics, it's not good enough just to look at the transaction log. You have to take what you get from the transaction log and also compare that to what's on the actual data page to understand the full picture of what the transaction was. If you focus on just a transaction log, in most cases, you will be okay, but you will come up to some situations where you're going to get an incorrect value because you didn't reference what was on the actual data page, and if SQL Server is smart enough not to write a value over top of the existing value. Does that make sense? Yes, sort of? Okay. Next, insert operations. Again, we see the begin transaction, commit transaction. Insert rows, this of course is an insert statement. Again, we track the transaction ID. We got the page ID, so the actual page that had the data row inserted into it. And the slot ID, meaning what slot, what row within that data page has been inserted. The offset in row is null, of course, because we're inserting an entire row as opposed to just a column. So in order to figure out exactly what was done in the insert statement, you need to reconstruct the data row. So looking at your transaction log, row log content 0 contains the following string. This string might seem pretty intimidating here, but what this is the actual data row that was inserted as part of that transaction. And to understand what that data row is, we're going to need to know how SQL Server stores information within that data row. So again, looking at the schema as we did earlier, it's the same order table. And to reconstruct the data row, we need to understand, again, what that structure of the variable length data row is. I don't want to go into too much detail here, but the gray bits are overhead. And the areas I want to focus on are the fixed length columns, which are highlighted in yellow. So all of the fixed length columns are stored in the order of the call order results that we got earlier. And any variable length columns are one huge string that's stored at the end of the data record. And item 7 is a row offset, and that marks the end of each variable length column. So for each variable length column, there's going to be a 2-byte value within block 7 that tells us exactly where each variable length column will end. So it will tell us where one column ends and the next column begins. So taking that into consideration, again, I kept the same colors in the slide for you. The overheads in gray. Then we have our fixed columns in yellow. So we have the order ID column, the city column, the state column, the zip column, ship status ID column, order date column, and the price column all together. We have additional overhead. And just before the first blue box, which is first name column, we have the positions where the variable length columns end. So if you take a look, you can see the actual, let's see if I get my mouse going here. So we actually have the 2-byte representation of exactly where the variable length columns end that are highlighted in blue. So the large string of data we had before, we can actually slice and dice based on how SQL Server stores data within a variable length data row and figure out exactly what hex belongs to what column. Now that we have the hex representation, we know the schema of the table. We're going to swap the end in bytes. We're going to translate the data types, whether that's from hexadecimal to ASCII or from hexadecimal to decimal. And once we translate the types, magic, the inserted record was order ID 4122, and we have the first name, last name, address, credit card number, etc. And this guy inserted a record into a table that bought an Xbox 360 for $4. Not bad. Next, delete operations. For delete operations within SQL Server, when a delete statement is executed, what SQL Server does is it marks the records that are part of the delete statement as ghost. What that means is just a single byte which is switched, and by that byte being switched, it means that that record or those records are hidden from any statements or any results that are returned by the SQL Server. So as long as a record is marked as a ghost, it won't show up in any select statements, it won't be included in any insert, update, or delete statements you execute. The data is still stored within the actual data page within SQL Server, which is great. The bad news is there's a ghost record cleanup process, and this runs every couple of minutes, and it blows away all of the ghost records. So ghost records are fairly rare to come by. The only way I've personally been able to see a ghost record is to start a transaction, not commit it, that had a delete operation, and then examine the actual data page. And you can actually see that ghost record there. As soon as you commit the transaction, usually a couple seconds later, that ghost record is gone. But more good news, if you look at the delete operation within the actual transaction log, the delete rows, we get the page ID that the row was deleted from, and the slot that contained the original row. But the row log content 0 contains the same structure, which is the actual data row that was deleted as part of that transaction. So following the same process we followed earlier with the update statement, or the insert statement, excuse me, we can use the schema of the object that we just deleted the row from. We can map the hexadecimal to the appropriate columns, the appropriate overhead areas, and we see the same order ID, column ID, city column, etc. We translate the bytes, data types, and we can figure out exactly what that deleted data record was. And this record was for a 62-inch plasma TV for $3,500. So in terms of the transaction log, we just walked through how to retrace inserts, updates, and deletes. And now what about selects? The select statements are stored within the plan cache. The goal for that is just to review applicable statements within the scope of the investigation. So if the scope of the investigation is within the last 24 hours, you want to take a look at entries that were logged, of course, within that period. And any database that's the back end to an application, applications today, in most cases, developers are extremely efficient in how they write queries, meaning they're only going to select the correct columns that they need and provide adequate criteria against that to limit the results that come back. So by examining the plan cache, you're going to find a lot of activity that might be select star from credit card numbers, meaning when an attacker gets access to a database that he's not familiar with, he's going to need to do some sort of reconnaissance to figure out what the structure is, what type of data is stored within that database. There's going to be a lot of select star from this table, select star from that table, and that's going to light up the plan cache for you. And by dumping the plan cache, you can track these actual statements that were executed. Again, the inserts, the updates, the deletes, and map that to a SPID, and from there to an actual database user. Investigation pitfalls. What to look out for. Know the schema you're working with. When you're looking at the raw hexadecimal, things get real ugly real quick if you don't understand the schema behind the object that you're trying to translate. Once you know the schema for the object, you of course need to know what data types are involved, how values are stored, and how they're retrieved by SQL Server. Reduce large data sets. No one likes looking at hexadecimal, so the less time you have in there, the better. And again, correlate on-disk values with transaction log data. Don't just look at transaction log data because you can get burned and provide results that are inaccurate based on information that was on the on-disk value. Encryption. SQL Server 2005 introduced encryption, which is native. There's various ways you can encrypt data. Symmetric key encryption is the most popular. When you're looking at hexadecimal and you try to translate, you understand the schema, you understand the data types, you try and translate what's going on, and you're not making heads or tails out of it, there's a good chance that data might be encrypted, because SQL Server encrypts data prior to writing it to the log, prior to storing it within a database table. I'm actually contributing author of a book which is titled How to Cheat at Securing SQL Server 2005. I wrote the chapter on data encryption. Within this chapter, it shows you how to take a look at ciphertext, which is the actual hexadecimal, how to determine if that value is encrypted. If it is encrypted, what symmetric key was used to encrypt that actual data. Because what SQL Server does is when it encrypts data, it appends the key GUID that was used to encrypt to the actual ciphertext. So there's a script in there that I've written that will actually take a look at a string and tell you if it is encrypted and what key was used to encrypt it. So that could save you countless hours as opposed to racking your head thinking, why can't I translate this simple value? There's a good chance it might be encrypted. And last but not least, it takes time, so be patient. The first couple times, translating a insert statement or a delete statement, going through the variable length data rows might take a while. The more you do it, the better you'll get at it. My first time, I think I struggled for an hour on the first one. Now I can do them in about 10 or 15 minutes, so keep at it. Absolutely, absolutely. You can automate it. I wouldn't recommend automating it until you understand what's actually being done in the back end. Because when automation doesn't work or anti-forensics, you have to understand how it's done in the back end, exactly what's happening at a low level. But absolutely, it can be automated extremely easily, actually, in script. So, conclusion. Don't ignore the database when conducting forensic investigations. As we covered before, in the past, a lot of forensic investigations focus on just the event logs or the SQL Server error logs, but not the actual data files. There's a ton of information within data files and log files that just need to be gathered. So gather it, analyze them, get the information you need. That will help support the case that you're working on. On all of your DVDs that you got with BlackHat, I have a white paper in there. And that covers a real, well, it's a simulation of a real-world database forensic scenario. So it goes over when you get the initial call, when you're on site, how to validate something happened, how to acquire data, how to analyze data, how to set together your time.